Hey everyone, today we're going to be looking at a universal tablet Bluetooth keyboard. The tablet just slots into here and yeah, you pair it and away you go, but I believe it doesn't work because we have a problem with the charge port apparently. So it doesn't look too bad in there, but let's get the bottom off it. Just a couple of screws around the side and should pop off. They appear to be Torx bits. Have I got to kind of do the job? There you go. And is it clipped on as well? Quite possibly. I wonder if there's some screws under the feet. Have a quick look. Ah, there is two. Well, now it's probably just going to fall off without any effort. Hey. Oh, I see. Here we go. Right. Oh, yuck. Oh. Ooh. You can see the USB socket there. It's not even screwed on. It's just plastic stakes have been melted down in place to hold this, which means we're going to have to melt them to get this off, and then hope that they melt back into place nicely. You can probably use some hot glue, I suppose. What a horrible assembly method. Having a close-up look at this, like, it doesn't look too bad on the inside, but if we just check these here, that one's broken free, but it actually doesn't go anywhere, so it doesn't matter. That's a data line, I think, or is it something? That's ground. That's also a data line. That's a data line. We do have connections to those, and then this is our plus in, and that one is broken away. See it moving, so I think we just resolder that on and call it a day. There's a little bit of movement in the body of the connector, but it doesn't look broken. I think we'll get away with just a clean up, just because of the annoyance of having to remelt these stakes to get the board to hold into place. Not even sure if I have a socket that would do the job. Maybe one of those. Maybe. Ooh, maybe. Maybe I do it. Who wants to see me melt some plastic? Let's have a look there. Is it going to line up with that? Ah, what if I... Oh yeah, that could do it. Yep, I reckon that would do it. Is this worthy of a new socket? You know there's no going back if we can't make these work. Well, there is a lot of room in there for hot glue. I don't know what sort of plastic it is. It just looks pretty soft. I can scratch it pretty easily. Any markings on it maybe? It's probably just ABS, in which case probably fine to warm it up. First of all, I'm going to remove the wires. But, there you go. Now what we'll do is I'm going to use 180 Celsius at is it going to be a bit much? What do you reckon? 180 or 100 and should go 150. We'll keep a distance. That's metal, or is it? Or is that plastic? Oh no, it's plastic. Okay, being careful not to melt everything else that's at play here. I suppose I could fully disassemble the hinge, but I'm sure we'll be fine. This is a plastic clip over here, but I don't think we'll end up melting them together. Let's just see how soft it gets with 180. It's kind of softening up. There's actually a cutout at the top of the board there around that one, so you don't have to get all of that one. But what we'll find is when it's nice and soft, then we could probably just lift the board up off of the spike. See that? Now what I'm going to do is hold it there so that the bottom one is sitting inside the hole, and as it cools down it's going to harden to the inside diameter of the hole, which should hopefully keep it in a position to make it easier to slip back over if I'm cunning enough. Like that. So because I let it sit in the hole for a little bit and cool down, it's hardened to the diameter we need to slip it back over. This one's not so bad because, as I said, there's a cutout at the top of the board, and it'll just sit in under around there and pop back together, no worries at all. But they have put some double-sided tape under there, like they thought that was going to actually do anything important. Whatever. Let's take this off. If we have a closer look in there, it's oh, it is actually broken. I didn't think it was, but you can see there there's plastic floating around in there. It's kind of lower on this side than this side, so yeah, we'll chuck a new one on there. Just cleaning that off to flatten it out a bit. So I'm going to stick some tape on there to hold it. And the reason I'm going to tape it down instead of clamp it in the vise, because you could, if you're careful, just clamp it in the vise between the two jaws. But what actually happens is, because it's such a small piece of PCB, the doesn't take much clamping pressure. When you get it up to reflow temperature, the PCB softens, and the clamping force can cause it to bow either up or down depending on the position of the moon in the sky at the time, and that's just annoying. So small stuff like that we'll just stick down and work with it as is. Whoa, get back on the screen, you guys can't see anything. That'd be pointless, wouldn't it? It's probably a bit too hot as well. bit of flux to help them flow all the way through, and hopefully get a little bit of solder in there. Better. And did we get any stuff in the hole? Not too bad. There's always a little bit. I usually just brush it with a toothbrush and alcohol. It's the only way to really clean down in there. And how we look at there. Like a new one. Right, you want to see me attach this to the pegs again. Now, slip the top edge under that one, and remember how this one was molded into the right shape for the hole. It should just push over it, just like that. Now all we need is something that can flatten it back down again once it's hot, so a nice flat edge that we can squash it down with, and we'll warm it up to its melting point, which last time I had it at 180 or 185, but it took a while, so I'm just going to make it 195 this time and encourage it a bit quicker. Same low airspeed. We don't want to melt everything around it really. There's some tape under there that's squash that down as well. Oh, you can see that's almost folding out to its shape it was anyway. So it's nice and soft. Let's just hold that against the board. Take the heat away, of course. Let it cool off. And it does cool off pretty quick. There's a little bit of movement there. It could almost squash down a bit more. So let's do a bit on the top side. Let's squash that down. I guess a bit of movement in the PCB wouldn't be all bad, as it would help to locate the connector into the socket, but I don't think that's the goal. I'm just going to flatten the bottom one a little bit more. You can see the plastic here is starting to go a bit shiny, which is an indication that it's starting to melt, so you just want to keep your eye on that, of course. You don't want to melt everything around it. Because it will deform quite readily. Let's just squash that down. A bit more pressure this time. There we go. I think that'll do nicely. I think it's staked better than they did it. At least the bottom one. Look at that. No movement at the board. A little bit at the top. Ta-da! And let's plug it in and see how many amps this is drawing. What a horrible image. Although it's only an LCD, there's no backlight, it's not OLED, it's a really budget USB current meter. Plugging in. Oh, and we have nothing. Why do we have nothing? Could it be that the battery is so flat that it's gone and shut down? How many volts we got in our battery? We have 2.9. It's entirely possible that the charge circuit doesn't want to know about that. I just noticed that my connector doesn't go in all the way. What? It's not a non-standard size connector, and this is sitting in the same position that the other socket would have been sitting in, and it's now drawing 0.4 of an amp, but it's not ideal. It is really not ideal. You can see that these locking pins are supposed to clip up behind the hole, and you can actually see the edge of the connector come. Can you see it? Yeah, you can sort of see. You can see it come through the hole. As I push it forward, you can see it sliding forward, and it stops there. But it is now charging at 0.4 of an amp. So maybe it had to think about it, or maybe it just wasn't all the way in before. And of course, assembly is in the reverse order, which is I forgot to tell you the model number. It is a Brydge. Kind of looks like BRY6002-001. It's now blinking a red battery light. Yeah, it plugs in. Enough to pull half an amp. Probably should test it. So it's oh, turn on Bluetooth and see if we can find it. Pairing, connected. Alright. Aha, looks like it's working. Let's go to Google. Yay! Interestingly, oh, that's working. Alright. Well, I hope that was a not so pointless waste of your time. Thanks for watching, and see you next time.